So we're now on to problem 21. And this group of problems asks, tell whether each conditional is true or false. So 21 says true if 7 is less than 3. So this one already is true, and this one is we have to determine whether it's true. So in this case, if true, then false. And because the 7 is not less than 3. So this is the one case in a conditional where the result, so the answer is, for this conditional, for the if-then is false. If it had been true, true, then it would be true. If it had been false, true, it would be true. If it false, false, it would be true. But this is the one case where it's not this case. Okay, number 24. So we have, let's see, we have a statement on the left-hand side that says 8 is greater than or equal to 8, which is true. Then some second statement, which is false. So this is true. And if true, then false. Again, just like this one. This is the one case where the result is false. Okay, number 27 on the next page. Actually, so we go to a new kind of issue. So let's see. Number 27. Let S represent she has a bird for a pet. Let P represent he trains dogs, and let M represent they raise alpacas. Express each compound statement in words. So I need to add a bit of space on here. So what we have for 27 is not M implies P. Okay, so M is they raise alpacas. So the negation of M is they do not raise alpacas. And we are doing an if-then statement. So if they do not raise alpacas, then P. And P is he trains dogs. Then he trains dogs. Okay. I really shouldn't have to check whether this is right or not, but I just don't want to do something wrong here. If they do not raise alpacas, then he trains dogs. Okay, so that's correct. Okay, on to the next problem. Let's do problem number 30. And 30 is S and P implies M. So S and P, S is she has a bird for a pet. If, so this part, first part is the if part. If she has a bird for a pet, and then we have the and P, which is he trains dogs, and he trains dogs, then, so then we have the then statement, then she has a bird, then what's M? M is they raise alpacas. Okay, let's check the answer. If she has a bird for a pet and he trains dogs, then they raise alpacas. Okay. Sorry for the slowness of it. It's hard to read all the different things I have. Actually, I think I'm going to switch to my other glasses. I've got the safety glasses on, but I need to see up a little closer, so Hopefully I can still see the computer screen. That's my limiting factor right now, but I think I can with these classes. I just have to get a little closer. But okay, now I think I can read everything. Okay, so number 33 says, let B represent I ride my bike, let S represent it snows, let P represent the play is canceled. Write each compound statement in symbols. So we're going the other direction. So if I ride my bike, then the play is canceled. So B is if I ride my bike, then the play is canceled. So we have B implies P. Okay, 36. If I do not ride my bike, then it does not snow. So each of those are negations of the other statements. So if I do not ride my bike, then it does not snow. 39. It snows if the play is canceled. So it's really, if the play is canceled, then it snows is really the way this thing. So P is the play is canceled, implies that it snows. And it snows, it's S, so P implies S. Okay, let's go to the next grouping, 42. Find the truth value for each statement. Assume P and R are false, and true is Q. Q is true. So 42 is the negation of P implies the negation of R. So what we can do is we don't have to do a truth table because we've got certain things, but we do need to kind of column. So let's do P, R, not P, not R, and then not P implies not R. So what we have is we have that P is false. We have that R is false. So not P is true and not, oh, I must have something wrong here. So that should be not R. Okay, so not R is true. And then we do these two, and if they're both true, then the whole thing is true. The only case where this would not be true is if this were true and this were false, based on the truth tables. Okay, so we have P, then Q. If P, then Q. So we're going to do the same thing, except actually this one's easier. I'm not sure. All right, makes me worried that there's some trick, but I don't think there is. So you have P, you have Q, and then you have P, then Q. So P is false. Q is true. And since P implies Q, the only time the result is false is if this is true and this is false. So it's the other way around, so it's going to be true. Okay, so one last one, we'll do this grouping. So we have is not R or P, then P. Okay, so again, what we'll do is we'll list everything that we know. We have two variables, P and R. We have not R. Not R, not. Okay, so we get everything there. And then we have, in parentheses, not R in union with P. And then we have the final thing that we started with. So again, what do we know? We know that P is false. R is false. So not P is true, opposites. And then we did the union of not P and not R and P. So we've got true and false. In the union, only one of them has to be true for the thing to be true. So that's true. And then we take this, which is that, and that implies that. So we have true. This part implies false, which is the one case where the result is false. Okay.